It's been a busy couple of weeks since my last devlog, and I actually meant to do this devlog on Friday, but I didn't quite like how it came out, so I'm starting over on Monday. I released my latest prototype on Thursday, and I've added a few new things since the last devlog, but most importantly I've fixed all the freezing and crashing issues. And being able to play through it from start to finish has given me some realizations about the game. I've had a few design epiphanies I want to talk about, but I'll also talk a little bit about performance. The crashing and freezing issues turned out to be just down to one bug, which is arguably an engine bug. Creating and destroying signals is not thread safe, but some node types create signals automatically, like the sprite node, and once that happens, all kinds of corruption can happen and havoc ensues. I originally thought I might work around this by just creating all my nodes up front and having a pool that I could pull from in the dish generation thread, but that seemed wasteful and a bit messy, so what I've done instead is split my food class into two parts. First there's the food object class, which inherits from SimObject, basically my superclass for everything that you can drag around and interact with in the kitchen. Then there's the food core class that handles all the simulation, so now that's the only part used in the dish generation thread. And then I'm able to insert that core into a food object if it gets selected to be one of the NPC's dishes, so that it can be added to the scene and rendered where you can actually see it. So once I got past that, my first major design epiphany was I could make this more similar to a normal puzzle game by just giving you an easy way to preview the reactions that you've discovered. So I've decided in the ingredients section of the notebook, I'm going to add buttons where you can toggle on and off all the reactions you've discovered and preview what that will do to the food's flavor and other aspects. I haven't gotten the reaction buttons functional yet, but there's a mock-up in the latest prototype. You can at least see a readout of the initial state of each of the ingredients available. As part of this, I've also been rethinking the set of flavors and aspects that food should have, because ideally for realism there would be many different aromas, different textures, and at least 5 tastes, but maybe more because alien cultures might be able to taste things that we can't. But all of that at once would be just information overload. I don't think that would make for a good game. So instead I've come up with 6 flavor categories organized into opposing pairs: sweet versus savory, acidic versus rich, and for now, botanical versus mineral, but that might become animal in the future. Only these 6 categories will matter for scoring, but in the future I might add more descriptive words within each category purely for flavor text from the judges. In addition to this, I also have 6 textures currently, although it only shows the top 2, and only the top 2 will be used in judging, by which I mean the textures that are most prevalent within your food. I also have this new cook meter, which replaces the idea of a raw and burnt attribute that can be increased or decreased. Instead, this aggregates the minimum cook value and the maximum cook value across the entire food. Some substances don't have a raw end to their spectrum or a burnt end to their spectrum, but anything that does will contribute to this meter. Being able to see this full range makes it a lot easier to make sense of what's happening if you watch it while you're cooking. As part of this, I also rethought how reactions work and how aspects are calculated and aggregated and all of that, and it's led to a chain reaction of changes through most of the native code base. But it all seems to be working pretty well now, with one major caveat. I wasn't able to tune the cooking reaction so that I can ensure you can cook a meat from raw to an acceptable level without parts of it becoming overcooked with the heat diffusion system. So for now, I've re-implemented the simplified system I had in GD script before I switched over, and the thermal diffusion system is still there, but it's off by default. I've added another experimental toggle so that people can try it out in the prototype if they want to, and I might eventually bring this back if I figure out how to balance those reactions reliably. The next big epiphany I had after playing through this prototype all the way was I can ramp up the difficulty by just adding to the judging criteria as you go along. For example, the first 2 challenges might only be based on the criteria of the challenge itself, but then the next 2 would judge you based on how well cooked it is, being as close as possible to the center of that cook meter. And then after that I might add on flavor balance rules, after that maybe textures, and I'm still tossing around ideas like portion size or other criteria that would just hone in on their idea of a perfect dish in the end. This just seems like the most natural and easy way to have a ramp up of difficulty as you go through each season. So now I want to talk just briefly about performance, because I don't want to put together like charts full of measurements and everything. I just want to keep this simple. When I first ported over to C++, I was surprised that while it was a lot faster, it wasn't as fast as I expected. I started off by looking at Godot's built-in profiler, and I found that actually just one script that I had left in GD script was making a huge difference. With 40 food objects, I was running at 18 frames per second initially, and if I just turned off the cooktop element script, it went up to 44 frames per second. More interestingly, when I moved that function from physics process to process, that got me up to 30 frames per second, which is still a pretty big difference. Then I ported it to C++ and I got back up to 40 frames per second. After that I started looking at C++ profiling, and the major time sink there was compositing the layers of the food to create the final image. And I really don't need to do that. I can probably just have a different sprite image for each layer, and letting the engine composite them for me will most likely be faster. But I also implemented a couple of obvious workarounds that have improved performance enough that I just don't feel the need to bother with it right now. I'll come back to that more in the future, and maybe I will go into the charts of numbers then. And I think I'll leave it there because I'm eager to get back to actually working on the game. So as always, it really helps me out if you hit the like button, spread the word, and subscribe if you haven't already. And of course, thanks for watching.